Hello everyone, Triple N I here. This upload was not planned in advance as you can clearly see by the state of my being. Certain events have taken place which I feel need my immediate attention. Professor Sam Ben Yaakov, a popular electronics YouTuber whose videos enjoy a large audience including myself, recently uploaded a video debunking an article on the internet. I wish to disclose at this point that I was the author, and yes, that is my real first name. It should be clear from the setting of the video linked in the article that I was responsible for the production of the video as well, which irrefutably ties me to the article in question. I have been writing for the website since October 2018, during which time I was in high school. I have since graduated. Writing articles for this website and its sister websites has been my meager but sole means of income to fund everything that happens here. Firstly, I wish to express my sincere apologies for letting content of this standard pass. Secondly, I would like to offer an explanation to the points raised by Professor Yakov. In my defense, I would like to point out that the article was edited by the website before it was published, and for that reason, we shall take a look at the original article I wrote and submitted in comparison to what was actually published on the website. So, here are the two articles side by side. Here is the original Word file I submitted to the website, and here is what was actually published. As you can see, one of the first things that they changed was the title, and that completely changes the way this article is seen. I intended this article to be a demonstration of the concept rather than something that would actually be used for high speed digital signals, and the title makes this distinction very clear. As you can see, an entire paragraph was left out which provides additional context. There also seems to be a lot of content missed out in this section. There is also a small paragraph which seems to have been omitted in the final article, which explains my choice of the 741 op amp. It is also seen that I meant this as an example and not as an actual circuit that is supposed to be used in digital systems. As you can see, this entire section has been left out in the final article, which contains an explanation as to why I used the capacitor in the circuit. As you can see, the explanation for the symbols used in the formulas have also been left out of the final article. I just realized that the aforementioned video had not been linked at the end of the article, so here it is. I feel that this video provides a wealth of information and context that would have enriched the content of the article. First, we start with a sawtooth waveform that has superimposed noise. The reference voltage itself is noisy thanks to capacitive pickup. Both these factors combined can lead to the output of the comparator circuit having unwanted transitions. In this case, the peak-like nature of the output is due to the op-amp's slew rate. Adding the feedback and compensation network renders the output transitions clean. You can observe the changing threshold voltage with each high or low level. Some overshoot or undershoot is seen on the threshold waveform due to the addition of the compensation capacitor. Now I would like to take a look at specific instances in the professor's videos in order to provide an explanation based on the differences between the original article and the published article and other mistakes.
So if I look now at this tutorial, which is supposed to give us a solution for a high-speed digital signal.
That, of course, can already be explained by the fact that the title of the article was changed before publication, which makes it rather misleading. The original intention I had while writing it was that it would serve as a demonstration of the concept.
Now, in this tutorial, there are some equations for the threshold. Here is the threshold for the high and low threshold. And here are the expressions. Unfortunately, we can't identify what is R sub B and R sub H because they are not marked on the circuit.
As we previously saw, the explanation for those symbols was left out of the published articles, but that was present in the original.
The threshold, 24 volt, just doesn't make sense.
I take full responsibility for the mathematical errors in the formulas as published. I should have checked them before submitting my draft.
So one way to combat this would be to put a capacitor. Now what happened with the capacitor is that it sort of accelerated, speeding up the change and very quickly moving to the other state and locking the amplifier to the other state.
That is exactly why I added the capacitor as explained in the video and in the original article, but the professor puts it in much better language.
What I found is that there are many issues with it. First of all, it's not high speed.
That can once again be explained by the change in title.
Secondly, the power supply is 12 volt, which is really not suitable for digital system. And then we have a voltage level issue. The zero level is just too high.
My intention was that this was a demonstration rather than an actual circuit,
And then we have wrong equation for the threshold.
which is fully my fault.
And there is no explanation of this capacitor.
The explanations in the text and the video were omitted. With that being said, I would like to say that I will be more careful in the future. I will verify the accuracy of the formulas I used before publication, and I will work more closely with the website to make sure the content is not as misleading as it was this time. I would like to thank Professor Yaakov for taking the time to go through the articles and present the errors. Once again, I will make sure that such mistakes do not happen in the future, and to that effect, the article will be edited and republished. Thank you.